Yowzers. Welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho, and the sun. Perhaps not something to be quite so frightened of, Internet. Yeah, we decided to do a deep dive a few years ago, and we ended up in a place we never figured we would be. This is the closest star, El Sol, otherwise known as Helios, to some, the sun. It's 304 angstroms ionized helium, ultraviolet radiation. This new active region rising is quite interesting indeed. It's produced additional M-class solar flares, by far the most active region we've seen on the sun for quite a while. And let's get to some comments from yesterday. Thanks for leaving a comment, Brett. Brett says, in my opinion, I think you overuse the word, quote, warning, end quote, with coronal mass ejections. If it were a tornado, it would mean that tornadoes are in the area and very possible to get hit by one, and so on. So let me talk about that and the forecasting of coronal mass ejections. So I'll put some up on the screen here for you to enjoy while I talk about this. So coronal mass ejections, folks, for you new viewers out there, that's when a bunch of material exits the solar corona and starts advancing through the solar system. And what we're looking at here is the viewpoint from Lagrangian point 5, where stereo A is located, which puts Earth off to your right from this perspective. And we did see some coronal mass ejections here, all not in the Earth-facing vicinity. Now, about a year ago, I realized that I was forecasting coronal mass ejections before they occurred. It wasn't a thing that was done intentionally. It was just simply because I wanted to know what I would be putting on the next video. And to be prepared for that, that was when I realized that I was forecasting coronal mass ejections before they occurred. So when we put up a coronal mass ejection watch, that means that conditions are appropriate for a coronal mass ejection to occur. When I put up a coronal mass ejection warning, that means that one will occur. And nobody's more critical than me of this. So the accuracy over the past nearly 1 year now, we're at pushing 11 months, the accuracy has been 100% except for one failed prediction, which I lowered my watch. So I should have kept the watch up. I should have had more confidence and not second-guessed myself. That watch should have remained up. In fact, I think that was a warning that I just suspended as nothing. So we've had 0 false alarms for coronal mass ejection warnings, and we've had only 1 missed forecast over the past approximately 11 months. So that's why these things are listed as warnings and not watches. It all has to do with the likelihood of whether they'll happen or not. Currently, the SDO site is down, by the way. When the SDO site goes down, one of the places you can view solar data is something we show toward the end of the video in our bonus segments. The National Sunspot Observatory Hydrogen Alpha imagery is a good one. Also, you can also access the Soho. So if you click the Soho movie theater, you can download movies of various different wavelengths and so on. So this is how you do it with the Soho Observatory. There's a little bit of data in 171 angstroms. I won't spend too much time on that. I just wanted to let you know that the SDO site is down, but there are indeed alternatives. So we've got some more spectacular imagery of the closest star here to share with you at the end of the video. This is 131 angstroms, one of the ionized states of iron, the ultraviolet emissions from those iron nuclei. The whole atom, I'll say. The radial flux has come all the way up to 109 solar flux units, a major uptick. Here's the 1-year chart to put it in context. The black line here is the radial flux. The red line is the sunspot number, and you can see they are pushing up into the new solar cycle, big time. So here's a space weather enthusiast dashboard. Again, none of those coronal mass ejections are headed Earth's way. 3-day forecast does not include any geomagnetic unrest or space weather storms. We are seeing a bit of a drought here in 7+ magnitude earthquakes, so be prepared for 7 magnitude earthquakes if you're in an earthquake-prone zone. Here's the map. A bunch of earthquakes in southern Alaska. Once again, shout out to Brett. Let us know if you felt any of those quakes. Little history on me. I've been in many earthquakes, quite a few here in Pennsylvania, and I've never actually felt a confirmed earthquake. It makes me unduly freaked out about them. So no major quakes here, nothing over a 6 magnitude. There were some in the 5 magnitude range, several in the around the Tongan Trench. What is that called? The Kermadec Trench? Anyway, the area north of New Zealand saw a string of quakes. There was also one west of Kamchatka there, near Siberia. Some quakes in Hawaii. Also some showing up in La Palma. There was a deep quake at Fiji. I think the largest quake of the past 24 was this 5.4. Closest to Russia. So no major quakes. By the way, here's the webcam that we wanted to show you yesterday of La Palma. It's Kymedia or Kymedia.es. Kymedia.es/play. Kymedia.es/es/play. If you want to watch this La Palma webcam yourself. Spectacular view here of mainly some ash right now. We actually saw some incandescent lava when I was doing show prep. Let's see what else is erupting. Volcano rundown coming up. So La Palma continues to erupt. Some earthquakes there. None of the magnitude that we've seen. So the largest that we've seen was a 4.9, I believe. There was also a 4.6. These not quite as high as that. Some additional footage. There are some lava fountaining. It's about an 1,800-foot high fountain of lava there on La Palma. Correlated with an increase in earthquakes. Karimsky also on the list here, although volcanic ash not identifiable in satellite imagery. There could be a plume over Kamchatka. Please don't fly your ultralight John Denver-style aircraft over the caldera. Suwanosejima exploding. 7,000-foot ash plume over Suwanosejima. Luatolo, 8,000-foot ash plume as it explodes. Popocatépetl, 22,000-foot ash plume over central Mexico from the Popocatépetl volcano. Fuego exploding. 16,000-foot ash plume over Guatemala from Fuego. Revenador exploding. Revenador producing a 15,000-foot ash plume over Ecuador and fertilizing the landscape. Yes, volcanic ash, it's good for growing things. Sabancaya exploding, 24,000-foot plume of volcanic ash. Please don't pull vault the caldera. Please do visit our links. Welcome to the Neo-Renaissance. Visit smashomash.com to find all of our links. This one right here, smAsho merch, will lead you to today's featured product, which is the Mensa hat. So here's our store. I'll scroll down quickly. These are sorted in order of best selling. Congratulations on everybody that realized our stores exist and that our channel exists. Please support us as YouTube pays us just this side of nothing to put out the content. Again, today's featured product is the Mensa hat. I'm wearing one at the moment. Mensa. Make Earth not suck again. It's up to you, individual people, not giant heaving bureaucracies that can't even get out of their own way. Making Earth not suck again is your job. Tell your friends and foes. Direct them to smashomash.com. Click on the smAsho merch link. Perhaps become a member of the Smash team. All kinds of ways to support the channel and increase the probability these videos will continue to exist, remain publicly visible, and free for all to view. Next, looking at magnetic data. Stars are largely controlled by magnetic fields, or at least their activity is associated with changes in their magnetic fields. These are the magnetic fields around Earth, as measured by the GOES 16 and 17, and we're just in a moderate range here. Nothing to write home about, fairly consistently pitched curves here for the GOES magnetometers. Next, looking at the heliospheric current sheet while we're looking at magnetic data. Let's stick with the magnetic data. This is the polarity of the plasma that the sun puts out. And there's the latest image. You can see a North Pole current sheet once again on the way. And no predictions here. There's a lot of stuff going on. It's a little bit too chaotic for me to forecast the current sheet. So here's the line of sight view. It also shows you the solar magnetogram. Great 3D representation there of the ongoing solar polar field polarity flip. Here's the coronal hole plot. This is actually the best view to see the solar polar field reversal in progress. And you can see some magnetic indecision going on here around the eastern limb. We can't decide if that's north or south pole oriented coronal holes there. We'll have to stay tuned and wait for those to rotate in. So here's the visual of that scenario there. This is 193 angstroms from the SDO. This is the best wavelength that's showing coronal holes. And I definitely see this one up here. That's most likely associated with the North Pole there. So we'll just have to wait and see what happens with the coronal hole scenario. Likelihood of flare is still majorly high, which is why we're keeping our coronal mass ejection warning and solar flare warning in effect. Look at all the sunspots. I mean, we have multiple beta-class sunspot groups. This is also a beta-gamma class sunspot. So we've got at least 3 beta-gamma class sunspot groups. Likelihood of major solar flares continues to be very high. Let's continue on. So we've seen 3 M-class flares here over the past day. The past, I'll say, 36 hours. So that's significant. And it's mainly from this new sunspot up here. We've been seeing M-class flares before it's even in the earthly facing zone. So that's the area to keep an eye on. And when I say ion, the pun's intentional. No spikes in the proton flux. None of those flares have sent coronal mass ejections toward Earth. And let's go to the real-time solar wind. Real-time solar wind, not too exciting over the past 24 hours. Current conditions are, wait for it, it's a live applet. Just about 4 protons per cubic centimeter for the solar wind density, solar wind speed 389 kilometers per second. Fairly unremarkable. KP index, a measurement of global geomagnetism, is at 1. KP1 is the current situation. Nothing to write home about there. Here's the Magneto hydrodynamic pressure modeled by the Space Weather Modeling Framework over the past 4 hours. This data is courtesy of University of Michigan. And we're seeing fairly homogeneous pressure here. No real surprises likely to happen here. I did see that refreshed. I'm going to let it continue to play. Next, we're going to show you geospace delta B. Changes to Earth's B field at the ground level. Geospace magnetosphere movie ground magnetic perturbations. Since there's a polar excursion going on and because people are unduly frightened of it, we show the data daily. What we don't do is propagate nonsense and fraud on the internet about the sun and about the Earth and about space weather and about the galaxy and about generalized nonsense. Anyway, that's 4 hours of data. Those are changes to Earth's B field at the ground level. Next, a diagram of the solar system. Let's do a 7-day forecast. Here's where things are now. There's where things will be in 7 days, approaching another new moon, my favorite phase, as I am a reverse werewolf. See our previous videos during new moon periods for my definition of the term reverse werewolf. Next, a star chart. The moon is up near the apex of its flight across the ecliptic, which is this yellow line, the path the sun will take across the sky. We've also included the blue line here. That is the galactic plane. Mine faces the south. Let's do a cosmology segment. It's the Bat Nebula. Yes, what you're looking at here are the spectra of oxygen in blue and hydrogen in red or pink. So yeah, we've got some metals and some non-metals showing up here. In astronomy, we refer to everything more massive than helium as metals. It all has to do with the standard concordance model of stellar evolution, which I won't get into in this video. It's the daily space weather. And we integrate short cosmology segments into it. Make sure you check our playlists for more cosmology segments. We've got fascinating videos in our cosmology segments playlist, youtube.com/smashomash/playlists. This is located in the constellation Cygnus, my favorite constellation. Let us know what your favorite constellation is in the comments, and perhaps a description of why. If it's just your astrological sign, I don't even know if I want you to bother commenting. No, seriously, let us know what your favorite constellation is. So yeah, there's the Bat Nebula. I'm assuming they're putting it up because it's around Halloween. This is located at about only like 1,800 light years, I believe it is. 1,400 light years from Earth. So it's pretty close. And if you could see this with the naked eye, it would be about the size of the full moon. It's a pretty decent nebula. Today's random number is 81. It's going to coincide with some object here at the Neil Gehrels Swift Observatory transients page. Let's see what it is. It is indeed 4C67.05, a blazar, which is probably my favorite extragalactic object. My favorite galaxy class would be a blazar. What's interesting about blazars is that they have their galactic pole oriented directly toward us. Anyway, these are the hard X-rays from 4C67.05. Let's go to the Simbad portal to get to the CDS portal. So from the Simbad portal, you can click on CDS. That'll take you to a page that looks like this. And let's take a look at some spectra. So first we're looking at optical spectra, and there is that blazar. It must be located at quite a distance to be that dim. And let's see what it shows up in X-ray. So here it is on the Chandra. You can see it's a pretty bright X-ray source there, especially with respect to the surrounding environment. It's at a pretty dark part of space. There's a great view of that blazar in X-ray from the Chandra. Here it is on Pan-STARRS in optical bands Z and G. That blazar, it's a distant galaxy, and it's got its galactic pole oriented toward us. It could be a cosmic ray source, an extragalactic cosmic ray source, although it's very hard to tell because of the way cosmic rays are measured. Anyway, here's the 2-mass, that's the infrared, the thermal emissions from that blazar. It's quite bright across a large portion of the frequency range. There are the photometric points. You can see it's pretty much a full spectrum blazar. It's our featured cosmology object of the day, Galaxy 4C67.05, which is number 81 at the Neil Gehrels Swift Bat X-ray Observatory. On their transients page, that's today's cosmology segment. We kept it brief and we integrated it to the daily space weather. Electrons can charge up satellites, so can protons. At the moment, we don't see any of that going on. Here's the one-year chart of the electron flux, but we're seeing chaos in the electron bands. We'll get to that in a minute. Here's the 3-day chart as measured by the GOES 16 and 17. Pretty unremarkable there. Here's the forecast for relativistic electrons, and we're expecting fairly flat levels here over the next 3 days. I wouldn't tend to argue with NOAA on that. Here's a diagram of Earth's Van Allen belts because we're going to show you the total electron content forecast. Part of the plasmasphere and the entire inner Van Allen belt here is modeled. And if you want to read about this one, click on details. This is a model. It is showing chaos here. We're seeing some likelihood of very significant GPS errors over places like Indonesia, Papua New Guinea, any place where you see these orange to red colors. Most GPS errors occur around the equator at noon, and we're seeing some anomalies here over North America and Canada, as well as some less serious ones over Antarctica. That's a bit of chaos in the electron belts. And let's take a look at the ionosphere next. Located at about 300 kilometers of altitude, the F layer is represented in this imagery. It's your ionogram at vibrational frequency, megahertz, millions of vibrations per second. There's a lot of stuff going on above your head. Particle collisions, chemical reactions, the emission of electromagnetic radiation with things like the aurorae. And we're seeing some anomalies here once again. Let's bring up the latest image. That's 9:30 Universal Time. Here's the anomalygram. This is anomaly in megahertz from the 30-day median. And we've been documenting the last 2 daily space weather videos before today. We saw some serious anomalies around Central America. Today, less so. This is showing you low-frequency anomalies in red, high-frequency anomalies in blue. There's the latest image. That's 9:30 Universal Time. So there's the ionogram looking normal at that moment for the most part. There's the anomalygram. If you don't watch our meteorology segments, maybe you should check them out. we might teach you how to forecast your own weather. We're certainly going to do bonus features. First bonus feature is hydrogen alpha imagery from the Udaipur, India ground-based solar observatory, part of the National Sunspot Observatory that we referred to earlier. There you go. There's the latest. This was only less than 5 minutes old when we created the video. Let's see if the SDO site is back. And it does not appear to be. Those are old images of the intensitygram and colorized magnetogram. So we'll close things out with some additional imagery here of this new sunspot. I believe it's 2891. Don't quote me on that. Check out the awesome filament here in the foreground as well. Let's switch to 171 angstroms for a quick minute. Here's my favorite wavelength from the SDO. It's showing you the lower corona. It's great at showing magnetic looping, as you can see. And there is a coronal mass ejection showing up there as well. Part of that plasma did splash back onto the sun, by the way. So here's some additional imagery here of this new sunspot. The most active portion. The most photons, the highest energy photons, are emanating from this region. Fantastic imagery there from the SDO. We'll close out today's daily space weather video here at 94 angstroms. One of the best wavelengths to view solar flares, by the way. 94 angstroms, it's spectacular, as is your viewership. So thanks again for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, and may that solar wind be at your back.